Hello everyone, welcome to Automation Community. Today in this video, we are going to discuss about derived logic gates, that is XOR and XNOR. So let's start. XOR gate. The output of a two-input XOR gate will be on when one input is on and other input is off. As you can see in the table, the output Y is on when only one input is true. Then only output Y will be on. So when both the inputs are off, the output Y will be off, and when only one input is on, that means A is off, B is on, or one is on, B is off, then the output Y will be on. And if both the inputs are true, if both the inputs are on, then the output Y will be off. Similarly, XOR gate. The output is on when both inputs are the same, that is both 0 or both 1. As you can see in the table, when both the inputs are false, the output Y is true, and when the states of the two inputs is different, that means one is off and another is on, or one is on and another is off, then the output Y will be off. And when both the inputs are true, when both the inputs are on, then the output Y will be on. So now let's move to CODESYS, where we will draw a ladder diagram for these two gates and also simulate them. So I will open CODESYS. I will create a new project. Standard project. Okay. So I'll go to PLC PRG. So here we will draw the ladder diagram firstly for XOR gate. As you know, for XOR logic gate, the output Y will be on if the states of the inputs are different. When the states of the two inputs are same, the output Y will not be on. So either one input should be on and another input should be off, or first input should be off and another input should be on. Then only the output Y will be on. If both the inputs are true, the output will not be true, and if both the inputs are false, the output will not be on. So firstly, we will be using both normally open contacts as well as normally closed contacts for the output. So firstly, we will insert a normally open contact, and then we will insert a negated contact here but in parallel. And then we will insert here a normally closed contact, and here we will be inserting a normally open contact, and then we will insert a Y. So we'll understand what we have done here. So this normally open contact will be input 1, okay, and then this will be input 2. And we have used a normally open contact for input 1 and a normally closed contact for input 2. And this coil will be output 1. So output 1 will be on when input 1 is on and input 2 is off. So when input 1 is on, it will allow signal to pass through this, and when input 2 is false, this is a normally closed contact, so in false state the signal will pass through this. As a result, this output 1 will be true. Similarly, when input 2 is true and input 1 is false, then also output 1 will be true. So we'll use this normally closed contact for input 2 and this normally closed contact for input 1. Input 1. So here, when input 1 is false and input 2 is true, the output 1 will be true. If both the inputs are true, input 1 is true, input 2 is true, the signal will not pass through this, input 1 is true, input 2 is true, the signal will not pass through this input 2. As a result, the output 1 will not be true. So for input 1 to be true, the states of both the inputs should be different. One should be true, first one should be true, second one should be false, or first one should be false and second one should be true. So the states of these two inputs should be different, and then only the output 1 will be on. So for XOR gate, only one input should be true and another should be false. Either input 1 should be true or input 2 should be true. Similarly, we will now draw a ladder diagram and implement XNOR gate. So I will right click here and insert network below. So here we will draw the ladder diagram for XNOR gate. For XNOR gate, the output will be true if the states of both the inputs are same. Either both the inputs are true or both the inputs are false. So here we will insert a normally open contact, and then I will insert a negated contact in parallel, and then we will add a normally open contact here, and here we will add a normally closed contact, and then we will insert a coil. So this normally open contact will be input 3 and this normally open contact will be input 4. And here, if both the inputs are true, the signal will pass through this. As a result, this output 2 will be true. And similarly, if input 3 is false, and with that, input 4 is also false, these both inputs are normally closed contacts. In false state, the current will pass through this, the signal will pass through this. As a result, this output 2 will become true. So if the states are different, for example, input 3 is on, input 4 is off, the signal will not pass through this. Similarly here, input 3 is true, the signal will not pass through this, the output 2 will not be true. So for XNOR logic gate, for output to be on, the states of the two inputs should be same. Either both the inputs are true, the signal will pass through this, or both the inputs are false, the signal will pass through this. So now let's generate code here. Go to online and click on simulation. After that, we will go log in by clicking here. OK. After that, I will start. So as you can see here, for output 1, this is the XOR logic gate. Both the inputs are false. Input 1 is false, input 2 is false, and output 1 is also false. So for output 1 to be on, the states of the two inputs should be different. It should be different. One should be on, another should be off. If input 1 is true, the input 2 should be false. So let's see. Go debug and write values. So as you can see here, input 1 is true, input 2 is false, and the output 1 becomes true. And similarly, when input 1 will be false and input 2 will be false, then also output 1 will be true. So as you can see, if both the inputs are true, input 1 is true, input 2 is true, then the output 1 will not be true. This is the XOR logic gate. Only one input should be true. Only one input should be true and another should be false. Only one input should be true. Only one input should be true. This is false. Input 1 is false. Input 2 is true. Let's debug it. And you can see output becomes true. And for XNOR logic gate, both the inputs should be either in true state or in false state. And you can see here, input 3 is false, input 4 is false, the states of the two inputs are same, the output is true. And when I turn on the input 3, Let's debug it. So as you can see here, the states of the two inputs is different. Output 2 becomes false. And similarly, if I turn off input 3 and turn on input 4, and let's debug it, and you can see output 2 is still false because the inputs are different. The states of the inputs are different. One is false and another is true. Let's make both of them true. I will debug it, and you can see both the inputs, input 3 is true, input 4 is true, and the output becomes true. And when I turn off one of the input, output becomes false, and when I turn off both the inputs, the output becomes true again. So for XNOR logic gate, the output becomes true only when the states of both the inputs are same. Then only the output becomes true. It was all about this example. Thank you for watching.